Hello everybody. In this video, we are going to study law of cosine. When do we use law of cosine? We use law of cosine to find the missing side or missing angle. But this time our triangle is not right triangle. If it was right triangle, we could directly apply SOHCAHTOA. So in the conditions that we cannot apply SOHCAHTOA because our triangle is not right triangle, then we apply law of cosine. Let's derive the formulas and do some practice problems. Let this triangle be triangle ABC. Then side BC will be side A because it's just across the vertex A. Side AC will be B and side AB will be side C naturally. Let this angle be alpha. Let vertex B be angle beta. Let vertex C be angle gamma. If we have B and C, but we don't know A, then we can solve for A using this formula. A squared is equal to B squared plus C squared, unknown side, two known sides, minus 2 times BC times cosine of alpha. So in this case, alpha, B and C has to be given. So you know two sides of the triangle and you know the angle between them. So you can find the third missing side. So using the same logic, if the side B is missing, then we apply A squared plus C squared minus 2 times AC times cosine of beta. If side C is missing, then A squared plus B squared minus 2 times AB times cosine of gamma. So this is how we can find the missing sides. Let's derive the angle formulas. In this formula, we can solve for alpha. So our step 1 is to subtract A on both sides and add 2BC times cosine alpha on both sides. So what we obtain will be 2BC cosine alpha on the left hand side is equal to B squared plus C squared minus A squared. We are solving for alpha, so we need to keep it alone. Now next step is to divide both sides on 2BC. So cosine alpha is equal to B squared plus C squared minus A squared over 2 times BC. Because we are looking for alpha, we need to arc cosine on both sides. Because inverse trigonometric function can release this alpha. So we are going to arc cosine on both sides. So alpha will be free here, then alpha angle alpha will be equal to arc cosine of B squared plus C squared minus A squared over 2 times BC. So in this formula, if you're looking for angle alpha here, then B squared plus C squared minus A squared. So this angle alpha and negative A squared has to match. And B and C has to be here. Let me use the same color coding. B and C is here. Angle alpha, because it's on the vertex A or across the side A, so it's going to be in negative A squared form here. So using the same logic, we can derive angle beta and gamma. So angle beta will be equal to arc cosine A squared plus C squared minus B squared. Our angle is matching with our side B over 2 times AC. And our angle gamma will be equal to arc cosine of a squared plus b squared minus c squared over 2 times ab. Here you have to be careful that your calculator has to be in degree mode so your angle comes out correctly. You can directly apply this angle formulas, or you can plug in the formula and solve for alpha step by step. Let's practice now. Problem number 1. We are given triangle ABC. We are given side CA, CB, and we are going to find side AB. And we are also given the angle between two known sides. So 28 is our side A, because it's just across vertex A, and 16 is our side B, and unknown side is side C. So we're going to apply direct law of cosine formula. In our case, missing side is C, so we're going to apply C squared is equal to two known sides, which is A squared plus B squared, minus 2 times AB times cosine of C. Here all we have to do is just plug in the numbers. Here, if we square root on both sides, we obtain C is equal to square root of A squared plus B squared minus 2 times AB times cosine of C. Now we are going to plug in the numbers and calculator will take care of this. A is 28, so 28 squared plus 16 squared minus 2 times 28 times 16 times cosine of 41 degree. Now let's do it on the calculator. Depending on your calculator, TI series or even online calculator, just be careful with the degree and the radian mode. For this problem, I'm going to use calculator.com. So our C is equal to square root of 28 squared plus 16 squared. This is our one group, minus 2 times 28 times 16 times cosine of 41. And be careful that your calculator is in degree mode. We highlighted degree mode here, and you need to close the parentheses. So it's gonna be in order of operation, or you can do it manually by hand, step by step, each value, and then follow the order of operation. So our answer is 19.07. So our C is 19.07. To the nearest tenth, it's going to be 19.1, or to the nearest whole number, it is just 19, depending on what they are looking for. Let's continue with problem number 2. We are given triangle XYZ. YZ is 30, XZ is 21, and the angle Z is 120. So we're going to find side Z. So we're going to apply direct formula. So Z squared is equal to Y squared plus X squared. So these are the known given sides. This is the missing side. Minus 2 times XY times cosine of Z. And if we solve for Z here by square rooting on both sides, we get Z is equal to square root of, let's write in the alphabetical order, X squared plus Y squared minus 2 times XY times cosine of Z. Now all we have to do is just plug in numbers and calculator will take care. So Z is equal to, our X is 30, our Y is 21, 2 times 30 times 21 times cosine of Z, which is 120 degree. Now let's use the screen calculator. So we're gonna have square root of, we need two parentheses here for order of operation, 30 squared plus 21 squared is one group, close parentheses, minus 2 times 30 times 21 times cosine of 120, and make sure your calculator is in degree mode. Don't forget to close the parentheses, and the answer will be 44.39. And nearest tenth will be 44.4, and nearest whole number will be 44, depending on what they are looking for. Let's check this example. We are given triangle ABC, side AB and C are given. We are going to find the angle measure of A. Here we can directly apply A squared is equal to B squared plus C squared minus 2 times AB times cosine of A, and solve for A step by step, or we have just derived the formula that A is equal to arc cosine of B squared plus C squared minus A squared divided by 2BC. You can directly use the formula you derived, or you can go step by step from here. So be careful that the angle has to match with this side, and these two sides has to match with the denominator here. So we're going to solve for arc cosine of these numbers. Let's plug in. So angle measure A will be equal to arc cosine of, you can use either notation, B is 7 squared, C is 10 squared, and A is 14 squared, divided by 2 times 7 times 10. Let's go to our calculator and find the answer. So here we are going to click on inverse trigonometric functions. We're going to pick up arc cosine, and we need two groups of parentheses, one for numerator, 7 squared plus 10 squared minus 14 squared, and another group is for the denominator, so 2 times 7 times 10. And make sure your calculator is in the degree mode. So our angle is 109.61. So nearest tenth will be 109.6, and nearest whole number will be 110 degree. So depending on what the problem is looking for, you can pick up one of them. So our angle measure A is nearest whole degree is 110 degree. This is problem 4. We are given triangle ABC, we are given side C, and we are given side B, and we are looking for angle measure B. We are looking for angle, but we don't have 3 sides given. So we're going to go 2 steps. Step 1, we're going to find the third missing side, which is side A. And then, when we have 3 sides, we can find the angle directly applying the formula. Let's go ahead. We know that missing side A squared is equal to B squared plus C squared minus 2 times BC times cosine of A, according to law of cosine. So here we have A is equal to square root of those all numbers. Now we can plug in and calculator will tell us. So our B value is 17, our C value is 22, and 17 times 22 times cosine of 150. Now let's plug this in our calculator. We have square root of 17 squared plus 22 squared, close this group, minus 2 times 17 times 22 times cosine of 150. Make sure close the parentheses, otherwise the order of operation might not work. And make sure your calculator is in degree mode. So we're going to have 37.69. Let's keep in 2 decimal to get more exact angle here. Or you can round up to 38 if you wish. Now we're going to apply this step 2. In step 2, we can use this formula and solve for b step by step, or we have just derived the formula. B is equal to arc cosine of a squared plus c squared minus b squared all over 2 times ac. Our a value is 37.69 and our c value is 22 and our b value is 17. 2 times 37.69 times 22 wrapped in arc cosine. So that's gonna be our angle B in degree. So let's go to our calculator. We can start over to show. Click on inverse, pick up arc cosine. We need here 2 parentheses, one for numerator, one for denominator. So 37.69 squared plus 22 squared minus 17 squared, close parentheses, divided by the denominator. 2 times 37.69 times 22, close parentheses, and make sure your calculator is in the degree mode, and your answer is 13.04. And nearest degree is 13 degree. So we know that our B is 13 degree. And if they are asking for C at the same time, you don't apply the formula again. You use the angle sum, totally 180. So angle C is equal to 180 minus 150 plus 13, which is going to make 17. So our angle C is 17. Altogether, 13 plus 17 plus 150 is 180. That's the total sum of the interior angles of a triangle. That's it for law of cosine. We practiced all possible problems that you might come across. If it is a word problem, as long as you construct the triangle correctly, you can follow the guidelines. Thank you for watching.